There are many types of layout tools, including specialty items to accomplish specific layout tasks. In this video, we will focus primarily on two of the most commonly used tools, the combination square and the sliding T-bevel. These two tools will service the majority of your layout needs. The combination square is the most versatile of all squares. Although not as accurate as a tri-square or framing square due to its sliding rule, the combination square can accomplish more layout tasks. It consists of a metal rule, also called the blade, and a 45-90 head which slides along the length of the rule. The best quality squares have their marks etched into the metal instead of stamped or printed. You can see the difference here. Etching is more accurate and will not wear off over time. When sliding the head, loosen the threaded nut which secures the rule and push the spring-loaded bolt in slightly so the rule can slide freely. The rule rests on two raised metal areas. If pressure is applied while sliding, the rule can wear down the steel and cause the square to become inaccurate. Lock the head in place by tightening the thumb screw. The rule typically has a different graduation on each edge and can be installed with the preferred edge adjacent to the head. This side of the rule has 1/8 inch and 1/16 inch graduations. The opposite side of this rule has 32nd inch and 64th inch graduations. Install the rule in the preferred orientation. Notice that the locking bolt may have to be rotated depending on the orientation of the rule. Combination squares can be equipped with protractor heads and centering heads. Protractor heads allow angles of any degree to be laid out. Loosen the blade lock and set the head to the desired angle. Then, retighten the lock. Centering heads are used to find the center of round stock. 2 or more marks are required. The 45-90 head is used for most layout tasks. To square a line across the face of a board, measure and mark the spot with a V where you want the line to be located. Hold the square firmly along the edge of the board and use your marking tool. Pencils are most common, though some woodworkers prefer to use marking knives. Make sure your line passes through the tip of the V mark. Traditionally, squares were equipped with a scribe in the head, which was used for marking. To continue the line around the board, move the square to the next edge and carefully transfer the mark from the previous line. Repeat the process until the line extends around the board. Always use the most stable surface to place your square. Placing the square on a small area will be less accurate. Avoid squaring from the end of the board, as it is less reliable and the end may not be square to begin with. To check a board for square, hold the head tightly against one surface of the board with the blade across the adjacent surface. Holding it up to the light will make it easier to detect minor inaccuracies. Combination squares are useful for marking mortises and hinge gains. To mark a mortise, lay out the mortise width on your board. Slide the blade to the desired position and lock it. Carefully slide the head along the face of the board, holding your marking tool in place. Flip the square over to the other face and complete the process. Using both faces will ensure the mortise is centered on the stock. Complete the mortise layout by marking the ends. Did you notice that I'm using a vise to hold the material? Doing so will allow you to focus your attention entirely on laying out, giving you better results. The process for laying out a hinge gain is similar. Determine the distance parallel to the edge and set your square. Then slide it along the edge of the material. Complete the layout by squaring the ends. Angled lines can be laid out with a combination square or a sliding T-bevel. 45-degree lines can be laid out with the standard head. Any angle other than 45 or 90 degrees will require a protractor head. If you do not have a protractor head, then you will need to use a T-bevel. Like combination squares, T-bevels come in a variety of shapes and sizes. Most will have a locking feature allowing you to secure the blade at a preset angle. T-bevels are used to measure, transfer, and lay out angles. To transfer or measure an existing angle, unlock the blade, hold the base of the tool against the edge of your stock, and align the blade to the angle. Carefully lock the blade in the desired position. The angle can now be measured or transferred to another piece of material. To measure an angle, you will need either a protractor or a bevel gauge. Hold the T-bevel onto either. If you are using a protractor, make sure the blade passes through the 0 point or your reading will not be accurate. Bevel gauges are easier to read and provide more accurate results. Digital bevels display the angle reading, often to 1/10 of a degree, but care must be taken to ensure they are properly calibrated. To lay out an angle, simply reverse the process. Use a bevel gauge or protractor to set the angle, then transfer it to your stock. Sliding T-bevels and squares are useful for setting up and checking machinery. For example, squares can be used to check that a saw blade is square to the table. Be careful when using a sliding T-bevel that the blade does not extend past the body, as this will result in an incorrect setting. Squares and T-bevels are used for many layout tasks. To ensure accuracy, treat them with care. Squares which are dropped may no longer be reliable. To check a square, select a piece of material with a straight edge. Draw a line perpendicular to the edge. Flip the square 180 degrees and draw a second line in the same position. If the square is accurate, you should see no deviation from the first line. As with any tool, its performance is only as good as the condition it is in. Take care to keep your tools from being damaged by handling and storing them properly.